If you need to pass GED Science, know that I made this video to help you pass faster and get a higher score. And in this video, we're going to walk through practice questions together, and I'm going to show you tips, tricks, and strategies along the way to help you move ahead to bigger and better things in life like college, a better job, joining the military, whatever your goal happens to be. I really hope that this video helps you move ahead with your GED studying, and we're going to get started right now. Small savanna ecosystem includes lions, zebras, gazelles, and grasses. Based on this simplified food web, what would most likely happen if the lion population increased? Is the answer A, B, C, or D? So now's your chance, if you'd like to pause the video, take all the time you need to figure this out, and whenever you're ready, unpause the video and we'll talk about it. Okay, so let's talk about this question here. So first, let's clarify what the arrows are showing. So if you just look at this, it kind of looks like the arrows are saying that the zebras eat the lions and the gazelle eats the lion because the arrow's going from the gazelle to the lion and from the zebra to the lion, but it's actually the other way around. So the arrows are showing energy transfer. So the zebra eats the grass and energy is transferred from grass to the zebra. The lion eats the zebra and energy is transferred from the zebra to the lion. So it's important to keep in mind here that the arrows aren't showing what eats what, the arrows are showing energy transfer. And Tommy is playing the part of the lion today. So let's walk through these one by one here. So if the lion population increases, what would we expect to happen to the zebras? Well, we know that the lions eat the zebras, so if there are more lions around, we would expect the lions are going to eat more zebras. We would expect the zebra population to decrease. And same with the gazelles, right? So we know that the lions eat the gazelles. So if there are more lions around, we would expect that the lions are going to eat more gazelles. So we can take A and B out because it would actually be the other way around, right? We would expect that if there are more lions, there would be fewer gazelles and fewer zebras. So what about C? The population of grass would increase. Well, let's say that there are more lions and the lions are eating more zebras and gazelles. Well, we would expect that there's going to be more grass, right? We would expect the grass population to increase because there'd be fewer animals eating the grass. So again, the lions eat the zebras and the gazelles. If there's more lions around, we would expect the lions to eat more zebras and more gazelles. So if there are fewer animals around to eat that grass, we would expect that the grass population is going to increase. So C is the correct answer here. Which of the following statements is supported by the chart above? Please assume that room temperature is 72 degrees F. And I just used F as an abbreviation for Fahrenheit. And we see here we've got elements, we've got melting points, we've got boiling points. So let me give you a chance now, if you'd like to pause the video, try to figure this out, take all the time you need. And if you have any trouble with this at all, absolutely no worries, because we're just practicing for right now and we're just going to go over it. So I'll give you a chance to try this now if you'd like to. So this question involves the three states of matter, and those three states are solids, liquids, and gases. So when a solid becomes a liquid, we call that melting. So think about an ice cube. That's water in the solid form, and that ice cube melts to become liquid water. Now, when you take a liquid and it becomes a gas, we call this boiling. So we have solids, liquids, and gases, and we know that when a solid becomes a liquid, we call that melting. And the melting point is that temperature in which the state of matter changes from a solid to a liquid. And when you have a liquid and it changes to a gas, we call that boiling. And the boiling point is that temperature in which there's a state change from a liquid to a gas. So is copper a gas at room temperature? Let's look at the boiling point from our chart. So based on our chart here, the boiling point for copper is 4,667 degrees. So at room temperature, right, if it's 72 degrees, the temperature is not high enough for copper to boil because the boiling point for copper is 4,667 degrees. So A is out here. It's not supported by the chart above. So what about lead? Lead is a liquid at room temperature. Is that a correct statement supported by the chart above or no? Well, let's look. So we know that a solid melts to become a liquid, and we can see here that the melting point for lead is 621.43 degrees. So at room temperature, if there's lead in a room at 72 degrees, we know that it's going to be a solid because it's not hot enough in that room. The temperature's not high enough for it to melt because we know that the melting point for lead is 621.43 degrees Fahrenheit. So let's take B out. Now what about hydrogen? Hydrogen is a gas at room temperature. Is this statement supported by the chart above? Well, we know here that the boiling point for hydrogen is negative 423 degrees Fahrenheit, according to this chart here. So we know that at room temperature at 72 degrees, that 72 degree temperature is higher than the boiling point for hydrogen. So hydrogen is a gas because it boils at negative 423 degrees. 72 degrees room temperature is hotter than negative 423 degrees. So C is the correct answer here. In pea plants, yellow seed color is a dominant trait, whereas green seed color is a recessive trait. A combination of two dominant alleles results in offspring with yellow seeds. A combination of a dominant allele and a recessive allele also results in offspring with yellow seeds. However, a combination of two recessive alleles results in offspring with green seeds. The letter capital Y is used to represent a dominant allele, whereas the letter lowercase y is used to represent a recessive allele. The genotypes of the offspring are missing from the box below. Please determine what percentage of the offspring will have yellow seeds and what percentage will have green seeds. Now, down here we have capital Y, lowercase y, capital Y, capital Y. So big Y, big Y, big Y, little y. So now if you'd like to, let me give you a chance to pause the video, try to figure this out, take all the time you need, and whenever you're ready, just unpause the video and we'll go over this. Okay, so I want to start off by going over the different combinations here. So we know that a combination of two dominant alleles results in offspring with yellow seeds. And the dominant allele is the big Y, the capital Y. So we know that two capital Y's results in yellow. Now, we also know that a combination of a dominant allele and a recessive allele also results in yellow seeds. So we know that that big Y is dominant and that little y is the recessive. And we know that the combination of big Y, little y also gives us yellow. Now, the last sentence here tells us that a combination of two recessive alleles results in offspring with green seeds. So the only way that we can get green is the combination of two little y's. So next what I'm going to do is fill in this box here. So this first box right here, I see that right over here beside the box, I've got a big Y, so I'm going to bring that in. And this big Y up here, I'm just going to bring it down. So the combination in the first box here is big Y, big Y. And that's the same as down here, right? I've got a big Y here and a big Y up top, and I'm just going to put them together here. Okay, so now for this box right here, the combination is going to be big Y, little y. So I have that big Y over here, I'm writing it in the box, and this little y up here, I'm just going to pull it down here. And it's going to be the same thing down here, right? I've got a big Y over here and a little y up here, and I just pull that little y down. So now, what percentage here will have green seeds? Well, we know that big Y and big Y is yellow, and we know here that big Y, little y is yellow, and we know that the only case that gives us green is the combination of little y, and we don't have any little y combinations here. So the percentage that's going to have green seeds is actually 0. Okay, so the percent that's going to have yellow seeds is 100%. I'm really excited to announce that this video's champion shoutout goes out to a test taker who passed the GED and says, "I've been in college for 9 months now." Now, this is an older comment, so I'm sure the test taker is quite a bit further ahead than 9 months, but the point I want to make here is that, obviously, as you watch this video right now, I have no way of knowing exactly what your individual goal is. Maybe you want to go to college, or maybe you want to get a better job, or maybe you even have a job lined up right now and you need to pass the GED for that job, or maybe you want to join the military. But whatever your goal happens to be, I really do believe that the GED is a stepping stone to moving ahead, and if you stick with it even when it's hard, even when it's frustrating, even when it's tedious, and if you just keep going and persevere and you refuse to quit, someday you'll be looking back on this too. Tommy recorded the highest daily temperature in Champions World each day for 7 days. What is the mean highest daily temperature? Now, for this one, I don't have multiple choice answers, so this will just be for you to come up with your own answer on. And if you'd like to, you can pause the video, take all the time you need. Calculators are fair game. And whenever you're ready, just unpause the video and we'll go over it. So let's talk about finding the mean. So we find the mean by adding up all of the numbers and then dividing by the total number of numbers. So again, I just took each number here, 88, 90, 87, 91, and so on and so forth till I got all the numbers here. And so I'm going to add them up and I'm going to divide by the total number of numbers. And we know that we have 7 numbers here, right? 1 for each of the 7 days. So I'm just going to add up all of the numbers and divide by 7 here. And when I do that, I see that the answer is 89. So again, to find the mean, what you have to do is add up all of the numbers and then divide by the total number of numbers. And in this case, we see that the answer is 89. Tommy recorded the highest daily temperature in Champions World each day for 7 days. What is the median highest daily temperature? So now's your chance if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, just unpause the video and we'll go over it. Now, the first step to finding the median here is putting the numbers in order from smallest to largest. So on screen, as you can see here, I've put the numbers in order from smallest to largest. And in this case here, we've got 7 numbers, so we have an odd number of numbers. So all we have to do after putting the numbers in order from smallest to largest is pick out the one in the middle and we're done. So again, when you have an odd number of numbers, like 7, as we see in this example here, all you have to do to find the median is put the numbers in order from smallest to largest, and you just pick the middle number and you're done. So if we had an even number of numbers, what you would do for that is you'd again put the numbers in order from smallest to largest, and then you'd have to pick out the 2 numbers in the middle, and you'd add them up and divide by 2. So that's when you have an even number. But when you have an odd number of numbers, like 7 here in this case, it's even easier because you just order them from smallest to largest, pick out the middle number, and you're done. And the answer here is 88. Scientists use the pH scale to measure how acidic, basic, or neutral a substance is. Acidic substances have a higher concentration of hydrogen ions than basic solutions. Acidic substances have a pH below 7, whereas basic substances have a pH greater than 7. The table below lists the approximate pH values for 7 different substances. Based on the information in the table, what is the ratio of basic to acidic substances included in the table? So now's your chance if you'd like to pause the video, try to figure this out, take all the time you need, and then whenever you're ready, just unpause the video and we'll talk about it. So I'm going to walk us through this by first counting up the number of acidic substances and also counting up the number of basic substances. So we know that if it has a pH below 7, we know that it's acidic. So we've got apple cider, which is 3.7, tomato juice at 4.1, and Mountain Dew at 3.05. So we've got 3 acidic substances. Now, the rest we know are basic, right? So it says here, whereas basic substances have a pH greater than 7. So baking soda has a pH of 8, so that's a base. Seawater is 8.5, so that's basic. And then we've got household bleach at 13, which is basic. And then milk of magnesia, 10.5, is basic. So we've got 3 acidic substances and 4 basic substances. So the ratio is 4 to 3. So C is the correct answer here. Which of the following is a balanced chemical equation? Is it A, B, C, or D? So now's your chance if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so first here, I'm going to break these down one by one, and for the first one here, for A, I'm going to go more slowly, and then we'll get a little bit faster when we look at other answer choices. So what I like to do here, starting out, is I like to write LHS for left-hand side, and then I'm going to write RHS for right-hand side. And so we're just going to take stock of how many of each element we have on each side, and we're going to see if they match. So when I say left-hand side, what do I mean? Well, if you look at the arrow here, everything over here to the left of that arrow, this is what I mean by left-hand side. And everything over here to the right of my arrow, that's what I mean when I say right-hand side. So let's take stock of the elements we have on the left-hand side. So I see that I've got C, I've got H, and I've got O. And the same with over here on the right-hand side. I've got C, H, and O. So what I want to do is count up the number of each element on each side, and we're going to see if we have a match here. So these little numbers down here, these are called subscripts, and these numbers out front here, these are called coefficients. Now, if you don't see a little number, you just assume it's 1. So here we have H and this little 3. We look at the C and we don't see a little number, so we would just consider it 1. So what I want to do now is apply these numbers out front here. I want to apply that to every single element we have. So if I look at this 2CH3OH, how many carbons do I have? Well, it would be 1 carbon right here, and then the 2 out front. So 2 times 1 is 2. So I've got 2 carbons on the left-hand side. Now, how many H's do I have? Well, we see here that I've got this 2 out front, and I've got this H here with a little 3 beside it. So I do 2 times 3, and that gives me 6 H's. But then I also have this 1 H right here. So I do 2 times 1, and that's another 2 H's. So 6 plus 2 equals 8. So on the left-hand side, we have 8 H's. So how many O's do we have here? So I see that I've got 1 O right here. So I take this 2 out front, and I do 2 times 1, which is just 2. So then we come over here. I see that I have this 3O2. So I do 3 times 2, which is 6. So in total, I have 8 O's or 8 oxygens on the left-hand side. Okay, so now let's come over here to the right-hand side and we'll see if the numbers match. So I've got 2 carbons, right? Because I see I've got a C here and this 2 out front. 2 times 1 is just 2. And so now I've got this O right here and this little 2 down here. But I have this 2 out front, so I do 2 times 2, which gives me 4. Okay, so now I come over to this 5H2O. So I've got this 5 out front here. I've got this little 2 down here, so I do 5 times 2. And we can see right here that the H's are not balanced. I've got 8 on the left-hand side and 10 over here on the right-hand side. So we can stop right here. We don't need to keep going because we already see that the number doesn't match. So let's take A out. And for B, we're going to go a little bit faster. And instead of writing it out like this, for B, I'm just going to kind of eyeball it this time. So let's start off here. How many carbons do we have? Well, we have 2 on the left-hand side. So let's pop over here to the right-hand side and see how many 2's do I have over here. Or I'm sorry, how many C's do I have over here? Well, we see that I've also got 2 C's over here. So the C's match on both sides. So what about the H's? Well, on the left-hand side, I've got H with a little 3 down here. So 2 times 3 is 6. Then I also have this H here. 2 times 1 is 2. So from the 6 H's right here, and I add the 2 H's from here, so I have 8 H's in total. So let's pop over here to the right-hand side, and let's see how many H's I have. So 6 times 2 is 12, so it doesn't match, so we can rule this out. When we look at C here, I'm going to do the same thing. So we already know that there are 2 carbons and that there are 8 H's, right? Because this 2CH3OH is the same in A, B, and C, right? But let's break it down one more time here just for the sake of repetition. So we see that we've got 2 C's right here. I pop over here to the right-hand side, and I see that I also have 2 C's. The C's match. Let's move on to the H's. So again, for the sake of repetition, we'll break this down again. So I've got an H here with a little 3 beside it. So I do 2 times 3, which gives me 6. So far I have 6 H's. Now I see that I have another H here. So I do 2 times the 1 H, which gives me 2 H. So I do 6 plus 2 and get 8. Let's pop over here to the right-hand side and see how many H's we have. So I've got 4, and this little 2 here beside the h, so 4 times 2 is 8. So we see here that the number of h's matches on both sides. So if the O's match, we're done. We have the right answer. And if not, we'll come down here and we'll check D. Okay, so for the O's, I know that I've got this one O right here times 2 because I see this 2 out front here. So far I have 2 oxygens, or 2 O's. Then I also have this 3O2. So 3 times 2 is 6. So I get 6 from the 3O2, and then over here I have 2 O's. So in total, I've got 8 O's on the left-hand side. So let's check over here on the right-hand side. So I've got this 2 from the 2 CO2, so I do 2 times 4. Or I'm sorry. So I'm going to do 2 times 2 over here because I know that I've got this O with this little 2 beside it and the 2 out front here. So I've got 4 oxygen so far. And over here I've got 1 oxygen, and then I have this 4 out front. 4 times 1 is 4. So I've got 4 from the 2 CO2 and 4 from the H2O. I add that up, I get 8. And we know now that C is the correct answer here. So the next question says, the data in the table below represents the highest daily temperature in New York City measured over a 4-day period. What was the temperature on day 4 measured in degrees Celsius? So now's your chance, if you'd like to pause the video, give this one a shot, take all the time you need, and whenever you're ready, just unpause the video and we'll talk about it. What I'm going to do is take the temperature on day 4 in Fahrenheit, which we see here was 50, and I'm just going to plug it in down here for the formula, right? So I rewrite this here, and when I rewrite this, I'm going to take 50 and I'm going to plug it in here in place of temperature Fahrenheit. So if we just use a calculator, 50 minus 32 times 5 over 9, we see that the answer is 10. Now, if you don't like using the provided formulas, there are 2 quick tips that you can remember for temperature conversion questions. If you need to go from degrees Fahrenheit to degrees Celsius, what you can do is just subtract 32 from degrees Fahrenheit and divide by 1.8. And on the other hand, if you need to go from degrees Celsius to degrees Fahrenheit, you can take the temperature in degrees Celsius, multiply it by 1.8, then add 32. In my opinion, the one that we're going to go over next is the hardest question in the video. And if you disagree and you think a different question was harder, if you want to, please let me know down below in the comments. So without further ado, let's get into this video's Champions Challenge question. Which of the following is supported by the table above? Is it A, B, C, or D? So now's your chance, if you'd like to pause the video, try to figure this out, take all the time you need, and whenever you're ready, just unpause the video and we'll go over it. Okay, so let's go through these one by one here. So doubling the mass decreases the force by half when the object's acceleration is held constant. Is this supported by the table above? Well, let's find 2 cases where the acceleration is the same. So I've got 4 here and 4 here. So I'm going to call this case 1. And I'm going to call this case 2. Now it says here, doubling the mass decreases the force by half. So we see that in case 1, the mass is 10, and we see that in case 2, it's doubled to 20. So what happened to the force when we did that? Well, we see that the force was 40 in case 1, and we see here that when the mass doubles and the acceleration was held constant, the force also doubled. So this one's incorrect because doubling the mass decreases the force by half. We actually see that what happened is that the force increased by half. So what about B? Decreasing the force by half doubles the acceleration when the object's mass is held constant. So this first one right here with the 20, I'm going to call this case 1 this time. And this one down here with the 20 for mass, I'm going to call it case 2. Now it says decreasing the force by half doubles the acceleration. Let's see if that's true. So we see here that in case 2, the force was 40, and in case 1, the force was 80. So from case 1 to case 2, we see that the force was decreased, right? The force was cut in half. And we see that when the mass was constant, we see that the acceleration was also cut in half. So it's not supported by the table that when the force is decreased by half, the acceleration doubles when the mass is held constant. So we're going to take B out as well. So now what about C? Doubling the mass doubles the force when the object's acceleration is held constant. Well, if we go back to the first case that we looked at, where the acceleration was constant, right? We had the 4 and the 4. And we saw that when we doubled the mass, when the mass goes from 10 to 20, the force went from 40 to 80. So when the mass doubled, the force also doubled when the acceleration was held constant. So C is the correct answer here.